Okay, there we go. That froze again. Okay, so we are moving on to adding and subtracting rational expressions today. It's all the same rules that go to adding and subtracting fractions, except instead of having just a constant in the numerator and the denominator, we have expressions. Okay. All right, so let's think back to when we first started learning to add fractions. So let's say I have 2 over 7 plus 3 over 7. The denominators are the same, which means, what's the only thing we have to do here? Add the numerators. So this becomes 2 plus 3 over the same denominator, and then we simplify to 5 over 7. All right, so the exact same thing in this first set of examples. We're going to find the sum or the difference. And our first few, again, the denominators are like. So we have in A, I've got A over 15m plus 2A over 15m. So again, the denominators are already alike, so all I have to do is add the numerators together. So I have A plus 2A all over 15m. I do have like terms that I want to combine, so I'll put those together. 1a plus 2a is 3a over 15m. And then I want to see, is there anything I can simplify or reduce? Yeah, that 3 goes into 15 5 times, so we will reduce that, and in the end, our most simplified answer will be a over 5m. Right. So in this one, none of the variables were divided out, and so therefore I don't need to make a statement about the variable because I can already see the one variable we have, m, is in the denominator, so we already know what can m not equal. 0. M can't be 0. All right. So let's look at our next one. I can probably move this over a little. Okay, so in the next one, we've got 4 over y plus 6 plus y over y plus 6. And again, the denominators are already the same here, so I don't need to do any manipulating, and I just add across. I have 4 plus y all over y plus 6. And then again, just a quick glance to see, is there anything that we can simplify from here? Can we reduce anything? Simplify anything? Which one? Can we divide those y's out? No. So remember that in the numerator, y is attached to 4, and in the denominator, it's attached to 6. So since they're attached to something, we cannot divide any out. About the only thing I can do, and this is just a preference thing, I'm going to put the y in the numerator in front, just so that it's leading. But either way, both of those answers are equivalent. Okay, again, I did not simplify any variables out of the denominator, so I don't need to make another statement about the domain here, because we can already see what can y not be equal to. -6. Yeah, cannot be -6. Okay. So our next one, we've got 2m plus 3 over m minus 4 minus m minus 2 over m minus 4. So again, we will be very excited when the denominators are already the same. What part do we need to be careful with here?
The minus.
The minus, okay, because the minus it's subtracting this entire term here. And so we have to be careful to distribute. So I'm going to go ahead and write it all together. The numerator, 2m plus 3 minus, but it's going to be minus m minus 2, that m minus 2 in parentheses. Okay. the denominator is m minus 4. And so now I just want to be careful to distribute the negative sign through. So we get 2m plus 3 minus m, and then what happens to the 2? It becomes plus 2 all over m minus 4. And then I want to go ahead and collect my like terms. I have a 2m minus 1m. That's m left. And then I have a 3 plus a 2. That's 5 all over m minus 4. And can we simplify this any further? No, we're finished here. I did not simplify any variables out, so I don't need to make a statement because we already know by looking what can m not be equal to? 4. All right. Here are a couple for you to try. Let me move this one over so I can see them both. All right, so looks like we did pretty good on these. This one here came out to y plus 3 over y. And this one here is awesome. Most of you guys realize that once you got to this, that you were able to factor this down so that you can divide those out. And in the end, we end up with 1 over x minus 1. And I think that's probably the most common thing I saw. Forgot to tell me what x can't be. So don't forget when you have a variable in the denominator to address that. Okay, so overall, how are we feeling about adding and subtracting with common denominators? Yeah. Okay, because now we got to step it up and move into the unlike denominators. All right, so I'm going to start with just some simple fractions. Bless you. All right, so let's start with 2/3 plus 1/4. Okay, so the denominators are not the same, so we need to come up with the least common. So I look at my 3 over here. And the multiples of 3 are 3, 6, 9, 12, 15. We'll stop there. And we have 4 as our other denominator. And so we get 4, 8, 12, 16, 20. But again, we want the smallest of the common. So what's the smallest of the common? 12. The 12. Okay, so we know that 12 is going to be the least common. So I'll put a 12 down here and a 12 down here. All right, so for the 2/3, in order for the denominator to go from 3 to 12, we'd have to multiply it by 4. And if we multiply the denominator, we also have to multiply the numerator, and in the end we get 4 times 2, 8 over 12, right? And for our second term, in order for 4 to go to 12, we'd have to multiply it by 3. So if we multiply the denominator, we also have to multiply the numerator, so we get 1 times 3 is 3. So now we have a like denominator. We can add this across, 8 plus 3 over 12, which is 11 over 12. All right. So that's with integer values. What would happen if, say, I asked you to do 1 over a plus 1 over a squared?
You have to multiply the first one by a.
The first one by a. So again, if I started listing multiples out, for a, we would basically have a squared, a cubed. And for a squared, it would start at a squared and then go up. Okay, but least common, a squared. All right, our second one already has a squared, so we don't have to do anything with it, but the first one we'd have to multiply by a, and if we multiply it to the denominator, also have to multiply it to the numerator, and in the end we end up with 1 times a, which is a over a squared. And now we can add across a plus 1 over a squared.
Yes.
Yep. Okay, so essentially if you are working with a variable and an exponent, what is the least common multiple always going to be? The variable with which exponent? The higher exponent or the lower exponent? The higher one, the largest one. Don't know that number. Okay. All right. So let's look at a couple examples here. Let me move this one over some. Oh, that's not what I meant to do. I meant to do that. All right, and I'm going to move this over to give me a little bit of space to work with on that one. Okay, so in our first one, we've got 7 over 3m plus 5 over 6m squared. All right, so I have both a coefficient to work with and an exponent, a variable with an exponent on it. So if I look first at 3 and 6, what is the least common multiple of 3 and 6? 6 will be the least common. Okay, and if I look at the least common multiple of m and m squared, that's going to be m squared. So that means the least common multiple of the whole thing is 6m squared. All right, so knowing that I need 6m squared down here and 6m squared, what's nice about the second term? It's already 6m squared, so we don't have to do anything with that one. But in the first one, how do I get 3m to 6m squared? 2m. So if I multiply the denominator, I also have to multiply the numerator. And so now I have 2m times 7. That's 14m. Now my denominators are the same, so I can add across 14m plus 5 all over 6m squared. All right. Is there anything I can do to simplify? No. All right. Nothing factors out, so that is our final answer. The m is still in the denominator, so I can already tell what is the one number m can't be equal to? 0, so I don't need to state anything about it. All right, so our next one has a little bit more to it. So I have x over x plus 3 plus 3 over x minus 4. And so again, first thing I want to do is look at my two denominators. I have x plus 3 and x minus 4. Do either of those have anything in common? X, but remember, in x plus 3, what's x attached to? It's attached to a plus 3, and the other one is attached to the minus 4. So can you really factor anything out? No. So that means that the least common multiple will be x plus 3, x minus 4. Okay, so in the first one, x plus 3, x minus 4, I already have an x plus 3, so what is the only term I need to multiply in? The x minus 4. Yeah, x plus 3 is already there, so I have to multiply this one by the x minus 4, and also have to do it to the numerator. Okay. Now, in the next step, what I'm going to do is, once the denominators are alike, right, the numerators we have to simplify, which means we've got to get everything outside of the parentheses so that we can collect like terms. So I'm going to go ahead and do that in this step here. I have x times x is x squared, and then negative 4 times x is minus 4x. All right. Plus, in the other one, I already have x minus 4, so I need to introduce x plus 3 to this one. And again, if you multiply it to the denominator, you also have to do it to the numerator. So that's going to give us the x plus 3, x minus 4 in the denominator. And again, I need to go ahead and get everything out of the parentheses. So now I have 3 times x, which is 3x, and 3 times 3, which is plus 9. And so now I can go ahead and collect all my like terms in my numerator. So I have x squared minus 4x plus 3x is minus x plus 9 all over x plus 3, x minus 4. Will we be able to factor and simplify anything out of here? No. So therefore we'll leave it like this. Since we didn't simplify any variable terms out, I don't need to make a statement about what x cannot be, because they're both still there and we can see them. Yes?
Would it still be considered correct if you solved the denominator?
You mean if you distributed the terms? Yes, but I wouldn't do it. You're just creating more work. All right. Let's look at C. So looking at C, we've got r over r squared minus 16 minus 5 over r plus 4. Is there anything that stands out to you about this one?
Yes.
What is it?
Difference.
Difference of two squares. Okay, so whenever we are trying to find a common denominator, the best thing to do is to factor all of your denominators first. Okay, it'll make it much easier to find the least common. So I'm going to start by factoring that one. So we get r over r plus 4 times r minus 4 minus 5 over r plus 4. Okay. So now is it much easier to see what the least common multiple is for the denominator? Yeah. So our least common multiple for our denominator will be r plus 4, r minus 4. All right. So that's nice for the first one because do we have to introduce anything into the first term? No, that one's already set, so we'll leave that as an r over r plus 4, r minus 4. What do we need to introduce to the second term? R minus 4. So r minus 4 times r minus 4. All right. What's the other thing we have to be careful with in this one? We have a negative. Okay, it's minus the whole thing. So I'm actually, as I rewrite this, I'm going to write it as a minus 5 times r minus 4. Okay, and so now I'm going to go ahead and distribute the numerator. R minus 5r, and then that'll become plus 20 all over r plus 4, r minus 4. And then collect our like terms. So we get 1r minus 5r, so negative 4r plus 20 over r plus 4, r minus 4. And is there anything else we could possibly factor out? We can factor out a negative 4. It's not going to do anything to help simplify, but at least it'll be fully factored now. So that'll become r minus 20, not 20, r minus 5 all over r plus 4, r minus 4. Any questions on what we did on this one? And again, we didn't simplify any of the terms, so therefore there's no reason to mention what r cannot be. All right, one last one here. I have 7k plus 2 over 4k minus 3 plus 8 minus k over 3 minus 4k. Is there anything here that kind of stands out to you? The denominators are different by a sign. So 4k minus 3 is not the same thing as 3 minus 4k, but can we manipulate this in a way that they would be the same? By negative 1, exactly. Okay. So you can think of it in terms of either factor a negative 1 out or multiply both. Seems like you guys prefer to multiply by negative 1 instead. So I'll multiply the numerator by negative 1 and the denominator by negative 1. All right, so that does nothing to our first term. This will keep this as 7k plus 2 over 4k minus 3 plus, I'm going to have to distribute that negative 1 through, so that's going to give me a negative 8 plus k, and in my denominator, that's going to make it a negative 3 plus 4k, which is the same thing as 4k minus 3. All right. So now my denominators are the same, so I'm just going to add across. I have a 7k plus a 1k, that's 8k. And then I have a 2 minus 8, that's minus 6, all over 4k minus 3. And is there anything we can factor out? Yep. We can factor 2 out of the numerator. So factoring 2 out leaves me with 4k minus 3 all over 4k minus 3. And then what happens? Yeah, and what's left over?
2.
So, doesn't 2 look a whole lot simpler than what we started with?
Yeah.
Yes. Okay, so factoring further doesn't always help you. Like in this case here, we factored out negative 4. It didn't do anything more. But over here, it did. Okay, so it's always worthwhile to factor fully. Yes.
Would you have to put k is not equal to?
Well, they're all gone at this point. We don't have any k's left. So from the original, we can see that k could not be 3 over 4 in either way. So, okay. All right. I've got 5 for you guys to try. Yes. A little bit of everything here. Some of them are a little more involved than the examples I did with you, but I think you can handle it. You know all your rules. Okay. So in the first one, what is our final most simplified form? An E.
28.
Okay, I'm going to start off by talking about E because a lot of you were making this more difficult than you need to. So keep in mind, if you can simplify from the beginning, always do that. And always, always, always factor your denominators, okay? If you factor your denominator, it makes things much easier. So right off the bat here, I see that I have an 8 over 12, which we can reduce to 2 over 3, okay? All right. And then also, what I'm going to notice is that x squared plus x, is that factorable? Yes, because there's an x in each one. So I'm going to factor this into x times x plus 1, which means now what happens?
You can take out the x.
Yes, this x will divide that x out. And so now what we have is 2 over 3x squared plus 1 over x plus 1. Okay, now if you didn't simplify that, can you still get to the final answer correctly?
Yes.
You can. You've just made it a little bit more work than is necessary. Okay, and again, the larger your numbers are and the more terms that you're trying to multiply in, you're more likely to make an error. So you kind of want to keep things as simple as possible to begin with. Okay, so now that we have simplified just that part, what is our least common multiple?
X.
3x squared and x plus 1. Yeah, because neither of those denominators have anything shared in common. So therefore, we just have to multiply the two together. Yes?
So, do you multiply like both of them by the LCM that you just came up with, or do you multiply them by different things?
You multiply them, but each one by the term that's missing.
Okay.
Yeah, so we know that this is the goal here,
Okay.
right? And so if I look at the first term, it already has 3x squared. So what does it need?
X plus 1.
It only needs x plus 1.
Okay.
So I'm only going to do x plus 1 to this one and x plus 1 to the denominator. For the second one, it already has x plus 1. So what's the only thing I have to introduce there?
3x squared.
3x squared to this one. Okay. So then, distributing this one over here, I get 2x plus 2, and then just plus the 3x squared because now my denominators are the same. And I'm not going to multiply my denominators through. I'm going to keep them in their factored form. So this is correct, but it's not the nicest form because what's the term we usually put in the front?
Largest.
The highest degree term. So that's the only thing I'm going to do is just rearrange. So 3x squared plus 2x plus 2 all over 3x squared times x plus 1. Sorry, what was your question?
Oh, I got it. Never mind.
Okay. Okay. How did F go? Okay. Okay, so F should have come out to x minus 6 over 6 times x plus 1. Okay. Are we okay on that one? Okay. Huh? Is your numerator, did you guys get the x minus 6 in the numerator?
No. I got x minus 5. No.
Okay, so let's take a look at that. Again, start by factoring first. What can we factor out of the first term?
6.
The 6 comes out. Yeah, so if we factor 6 out, we get 6 here, x plus 1 minus 1 times x plus 1. Which means what is our let me make some space here. What's our least common denominator now?
6x plus 1.
Yep. Least common denominator is 6 times x plus 1. The first term already has both of those, but the second term is missing the 6. So we'll multiply this one by 6 over 6. Okay, denominators are now the same, and so multiplying 1 by 6, and then not forgetting that we have a negative in the front, we get the x minus 6 over 6 times x plus 1. All right. G was a little bit more fun, yes? Yes? Okay. I didn't get a chance to see everybody's, but I saw a lot. 5m minus 4 all over m plus 3 and m plus 1. How are we on this one? Yes?
Should you factor out the negative 1 out of the top or no?
You can.
Okay.
Yeah. Any questions on this one? We're okay on that one? Okay. H was also a little bit of fun. Just a little? All right. We get x plus 2 over x plus 3. And what do we have to do in this one?
X does not equal negative 5.
Beautiful! Yay! Oh, and I was also a lot of fun, yes? What do we end up with?
X minus 2
Yeah?
over x minus 3.
Over x minus 3.
And x does not equal negative 4.
Beautiful. Okay. Any questions on any of those?
Oh, wait.
Okay. Are there a lot of places to make mistakes here?
Yes.
Yes. Okay. So number 1 is make sure you factor your denominators, especially because if you don't, you end up introducing too many terms, and the more terms you have, the more likely you are to make a mistake, just an arithmetic mistake. All right, so reduce as much as you can up front. Be careful. Don't worry about like skipping steps necessarily, especially if like these over here when you're subtracting terms, because once you multiply in, you have to remember that that negative sign has to be distributed to all the terms that follow. So be careful with those. Okay, so otherwise, I like to say these are sort of like those, like, you know, I call them the bookkeeping problems, just being really careful. Being careful with your signs, your distribution. Again, lots of places to make small mistakes that throw everything off. Okay, what's a quick way to check to see if your simplified form was actually correct?
You could, oh wait, you add the answer.
Yeah. What if I said, I'm going to let x equal 3, and I plug in 3. Oh, actually, it can't be 3. Wrong term. Can't also be negative 4. What if I say, let's let x equal 4, and I plug in 4 for all these x's?
Then
right?
And then you plug in the 4.
If I plug in the 4 in the simplified form, should they come out equal?
Yes.
Yeah, they should. So that's a quick way to check. Okay, so that's all we have for today.